Alright, hi guys. So, we're going to be going over the Unit 1 Topic 2 quiz review. That is pages 28 to 30 in your packet. We'll go over all of the problems, and you can also find the key posted to Canvas. So, for the first section, it says rewrite each radical in rational notation. So what we want to do is we want to go from radical form, so that is the nth root of x to the m power, to x to the m over n power. Sometimes we can do this right away, and sometimes there's a little bit more that we need to do to get it into a way that we can do this. So for the first one, we have the cube root of x squared. Remember, if you have a power, that is the numerator of the fraction. If you have a root, that is the denominator. So this becomes x to the 2/3. For letter B, to just turn the radical into a rational power, all you have to do is make it 1 over 5 to the 6th power. But if the question asks you to make it a power function, having it in this fraction form is not a power function. So you would have to use your knowledge of exponents in order to turn it into a negative exponent. The 1 would be in front, if you can put that there if you want to, and it would be negative 5/6. For the next one, if there is no root here, that means it's a 2, not a 1, a 2. So this is the square root of x to the third, so that is x to the 3/2. Number 4, similar to number 2, if you just want to put it in rational notation, 1 over x to the 9/4 is fine. But if they do ask you to turn it into a power function, that would be x to the negative 9/4. For number 5, it's important to note that the negative x is in parentheses, so that is being raised to the 2/3 power here. Make sure it's still in parentheses. And then you've got a negative 2 here over the cube root of x to the 7th. If you just want to put it in rational notation, it's negative 2 over 7/3. But if you want a power function, it's negative 2x to the negative 7/3 power. This next section is the same thing, but in reverse. So you're going from x to the m over n to the nth root of x to the m. This is where you're going to need a little bit more finagling if you have a negative exponent, because you can't turn it into a radical unless you have a positive exponent. So 7 is x to the 14/5, so that's the 5th root of x to the 14th, and 5 in the denominator becomes the root, and the 14 is the power. For number 8, we have x to the negative 7/8. You need to turn this into 1 over x to the positive 7/8 before you can turn it into a radical. You can't make a radical with a negative exponent, so you've got to use your knowledge of negative exponents to make it 1 over 7/8, and then make it 1 over the 8th root of x to the 7th. For the next one, x to the 5/2, you can do the square root with the 2 of x to the 5th, but the 2 is not necessary. If there is no number there, it is known that it is a 2, but it's not wrong. It's okay either way. Number 10, similar to number 7, 5th root of x to the 13th. Number 11, be careful here with the negatives. Negative 4 is just a number. That does not become positive. Only the exponent 14/5 becomes positive. That negative 4 still stays in the numerator. It does not go to the denominator, and it does not become positive because it's not an exponent. Once you do move that exponent, that 14/5 to the denominator, then you can turn it into negative 4 over the 5th root of x to the 14th. And then finally, number 12, x to the 11/7 is the 7th root of x to the 11th. All right, the next section is about even and odd. So it says determine whether the function is odd, even, or neither odd nor even. So remember, if something is x to a even power, 2, 4, 6, 8, that is an even function. And any number, regardless of whether that number is even or odd, if it's just a number with no x, then that is also considered an even function. Odd functions would be x to an odd power, so x to the first, third, fifth, seventh, etc. Negatives work the same way. -2, -4 are even, -1, -3 are odd. So this one, x squared, you have x to an even power, that is even, and then -9. Even though 9 is an odd number, it is just a number by itself, which means it's an even function. If you have any combination of even functions where they're all even, that means that the function itself is even. There isn't an example of that here, but if it was all odd, then it would be odd. Number 14, x cubed, that is x to an odd power, so that's odd, plus x squared, even, odd and even, any combination is neither. And then number 15, similar to 13, x squared is even, and then even though the number 3 is odd, it is just a number, so that's an even function. Even and even is even. As a reminder, even means symmetric over the y-axis. So number 16 is symmetric over the y-axis, which is even. 17 is odd. Odd functions are symmetric over the origin. An easy way to do this, to know if it's odd, is you flip it upside down. If it looks exactly the same, then it is odd. Number 18, this one is neither. This one in particular is symmetric over the x-axis, but that doesn't have any special name. For even, it's symmetric over the y. For odd, it's symmetric over the x. This one is neither. All right, for this next section, we're actually going to take a pause. Okay, so as a reminder, let's talk about some of the graphing stuff and how we can determine even or odd from the equation. So if you have an equation for a power function, it's going to be x to a power. If you have a positive exponent and the numerator is larger than the denominator, so top larger than bottom, then the first quadrant is going to look like this, opens up. If the denominator is larger than the numerator, then the first quadrant looks like this, opens down. If you have a negative exponent, numerator, denominator being bigger doesn't matter. The first quadrant is going to look like this, and you've got asymptotes on the axes. And then determining even or odd, if you have x to an even over odd power, then that means the function is even. X to an odd over odd power, the function is odd. X to an odd over even power, the function is neither. If you have even over even, that can always be simplified or reduced to one of these three options. So because of that, we can answer the following questions. So, and you can find that on the first day of generalizing graphs. I think it's day 2 of what we did. And there was more practice and a big chart on day 3. All right, so because of this, in this example, we have f of x is x to the negative 5/3. 5 and 3 are odd numbers, so this is odd over odd, which means this function is odd. So that's letter E. If we want to draw a sketch, we know that because we have a negative exponent, the first quadrant is going to look like this. And then because it's odd, it is symmetric over the origin. So that is why the other piece is over here. This branch is in the first quadrant, this one's in the third. There are multiple different ways that we can write the domain, but the key thing is that we have asymptotes here, the vertical and horizontal asymptotes on the axes. So as we go from left to right, we are hitting every single x value except for the vertical asymptote. So that is why I've excluded 0. And then same thing for the range. As we go from bottom to top, we're hitting every y value except for the horizontal asymptote on the x-axis. So that is why, again, the range is all the numbers except for 0. We're excluding 0. As x approaches negative infinity for the left-end behavior, we are going towards the horizontal asymptote y value of 0. We're not touching it, but we're going towards it. That's why we're approaching 0. Same thing on the right. As x approaches positive infinity, we are also going towards the horizontal asymptote of y equals 0. We do have the asymptotes listed here, horizontal asymptote y equals 0 and vertical asymptote x equals 0. For the next one, before we do anything else, we need to make sure that we change this from a radical to a power function. So that is going to be 4th root of x to the 5th is x to the 5/4. That is odd over even. Because my numerator is larger than my denominator, my first quadrant looks like this. And because it's odd over even, it's neither, which means that's the only thing that there is. For the domain, we are including 0 and going all the way to the right from there. For the range, we are including 0 and going up. We don't have a left end behavior because there's nothing here to the left. But for the right end behavior, as x approaches positive infinity, the function goes up towards positive infinity. Because we do not have a negative exponent, this one does not have any asymptotes, and like I said, it is neither even nor odd. Alright, the last thing we're talking about is the variation problems that we talked about on Friday. So the first couple, we're just setting up the equation. So the weight of a body varies inversely as the square of its distance from the center of the earth. It didn't give me variables here, but if you didn't use the same one as me, that's fine as long as you're consistent with what they are. So what I did was W for weight and distance is D. So I said the weight varies, so that's W equals K. And then inversely means we're dividing by the square of the distance. I call the distance D. Square of the distance is D squared. So W equals K divided by D squared. Then in number 22, the distance that an object falls from rest varies directly as the square of the time it has fallen. I call D is distance and T is time. Varies directly is just multiplying. So distance that an object falls varies, D equals K, and then directly means we're just multiplying the square of the time, so T squared. All right, and then number 23, as a reminder, this quiz is no calculator. So the letter B here, and maybe even letter A, you might have needed to use a calculator. For the problem on the quiz that is similar to this, or problems that are similar to this, they will not be numbers that are challenging, so you won't need to use a calculator. Not to say they can't be big numbers, but it should be relatively easy to do them without a calculator. So, number 23. To build 1 mile of sound barrier along the highway, the amount of time needed varies inversely with the number of workers and can be described by the equation T of W equals 30,000 divided by W, where W is the number of workers and T of W is the amount of time in hours. Letter A. How long will it take 150 workers to assemble 1 mile of sound barrier along I-270? So we don't know how much time it's going to take. That's what we're trying to find, how long. But we have 150 workers. W is 150. So I'm going to go ahead and substitute 150 into my equation. And I get 30,000 divided by 150, and that is 200. Okay, now this I feel that you could do without a calculator because you can get rid of the zeros, right? Okay, and then 30 divided by 15 would be 2, and then you keep these two zeros. Okay, so this one I think would be totally fair without a calculator. Letter B. If it took 375 hours to build 1 mile of sound barrier, how many workers were used? So this time we have T and we're trying to find W. So 375 equals 30,000 divided by W. What we're going to do is we're going to multiply both sides by W, so that way on the right the W's can cancel. On the left we get 375W equals 30,000. These will cancel, and this I did use a calculator for. 30,000 divided by 375, and I got 80 workers. So that is the review. I hope that you found this helpful.